Suppose that the water in a hot water heater is 80 degrees Celsius above room temperature. When you first turn on the faucet, the water coming out is only 3 degrees above room temperature. 10 seconds later, it has warmed to 17 degrees above room temperature. A logistics function would be a good representation for the increase in temperature of water from a pipe over time. Temperature, represented as T of x, increases as a variable of time, x, and the temperature has an upper limit of 80 degrees. Therefore, we can use the general equation for a logistics function. Note, don't forget to store your answers on your calculator. For the purposes of this tutorial, we'll be rounding to 3 decimal places. Now that we have a general equation, the first thing we do is solve for a and b by plugging in the information we know. We know that our upper limit is 80, so c equals 80. We can organize the rest of our information using a t-chart. Next, we'll select a pair of points to plug into the equation t of x equals 80 divided by 1 plus a times e to the negative bx. For this problem, we'll use 0 for x and 3 for t of x. We know the upper limit is 80 because the water temperature cannot exceed 80 degrees. Now, multiplication by 0 gives you 0. Anything to the 0 power is 1. Thus, we are left with the equation 30 equals 80 all over a plus 1. Through cross multiplication, we can simplify the equation to 3 times a plus 1 equals 80. Then we can divide 80 by 3 to get 26.667. Subtract 1 to find the value for a. A is equal to 25.667. Now that we have solved for a, plug 25.667 back into the equation to solve for b. It will be a similar process to solving for a. Begin with 17 equals 80 over 1 plus 25.667e to the negative b times 10. First, eliminate the denominator through cross multiplication. Then divide by 17. Subtract 1 so you're left with the equation 25.667e to the negative b times 10 equals 3.706. Then divide 3.706 by 25.667 to get e to the negative b times 10 equals 0.144. Now, let's eliminate the exponents by using logarithms. Since we are dealing with the constant e, it will be beneficial to use the natural log. The resulting equation is negative 10b times the natural log of e equals the natural log of 0.144. Now remember that the natural log of e is equal to 1. Therefore, negative 10 times b is equal to the natural log of 0.144. The natural log of 0.144 is negative 1.935. Then divide by 10 to find b. b is equal to 0.193. Now we can put it all together into the equation t of x equals 80 divided by 1 plus 25.667e to the negative 0.193x. Using the equation we have just determined, we can now find the point of inflection. The point of inflection occurs at the point t of x equals c over 2, or in this case, t of x equals 40. We can plug this into the equation above to solve for the x value for the point of inflection. Once again, let's begin by eliminating the denominator. Divide by 40 so the resulting equation will read 1 plus 25.667e to the negative 0.193x equals 2. Then subtract 1. Divide 1 by 25.667 to isolate the other side of the equation. Now use those logarithms again. The resulting equation will read negative 0.193x times the natural log of e equals the natural log of 0.039. The natural log of e is 1, so negative 0.193x equals the natural log of 0.039. So, negative 0.193x equals negative 3.245. Divide negative 3.245 by negative 0.193 to find x. So, at the point of inflection for this logistic function, x is equal to 16.769.